In data communications and networking, let us talk about network models today. So, what are the layered tasks? Why we have layers? We talk about layers in communication. We talk about, or we understand the ISO OSI model. Somebody says TCP/IP model. What are these? What are these layers in between? What they do? Let us take an example. There are concepts of layers everywhere. Now, you are two friends. Okay, you are two friends, yourself and your friend. Now you want to send a letter to your friend. You are A and B. He is B. You want to send a letter. Just imagine that you just post a letter, you just write a letter, place it in the envelope, and you send it. And B receives it. Okay, you don't have to worry about what is going on inside. Maybe he is in country C1 and you are in country C1, he is in country C2. But still, you are unaware of, after you uh, write a letter, put it in envelope, and just place it in your or put it in your mailbox. You are aware and you are confident that this letter will be received by your friend. Just imagine post office does what, and imagine one more thing. If this post office is not there, what you're going to do? How you're going to send this letter to your friend B? We'll be talking about the layers exactly in this sequence. So we'll talk about the sender, that means you, receiver, that means your friend, carrier, which means the post office, or the path which it takes in the hierarchy. Where are you? Where are these post office, and where are you? In which hierarchy your friend lies? So what I just said, an example I gave. This is sender, this is receiver. You write a letter, put it in an envelope, and drop in a mailbox. The letter is carried from the mailbox to a post office. The letter is delivered to a carrier by the post office. Here, actual transformation or actual transmission or parceling is done. Letter is sent from a place to another. It may be through, say, train or aerial route. It can take aerial route. It can say subsurface, means water surface transport. So, in the other section, exactly the opposite is happening. The letter is delivered from carrier to post office. The letter is carried from the post office to the mailbox. Now you pick up the letter from the mailbox, that is your friend, and he or she reads it. These are the tasks involved. So there are layer of works which are happening. In the same sequence, and of this analogy, various organizations, they were, I must not say forced, but they devise a mechanism. They devise the standards, guidelines, or the protocols, how they can easily make an arrangement so that the data can be delivered from one point to another with no problem, fast, accurate, with timeliness, durability, and all those what performance is required. So we'll start with the OSI model. This was established in 1947. The full form is International Organization of Standardization. So we'll change this, as we are aware that it is a multinational body dedicated to the worldwide agreement on international standards. So this is a standard making body. An ISO standard that covers all aspects of network communication. This standard for network communication is OSI model, or Open System Interconnection model, first introduced in 1970s. So we'll talk about the layered architecture, peer-to-peer processes, and encapsulation. ISO is an organization, please understand. OSI is the model. Again, OSI, Open System Interconnection, is a model. ISO is the organization which makes it. So these are the 7 layers of OSI model: A, P, S, T, N, D, P. That is physical, data link, network, transport, session, presentation, and application layer. This is how the work is going on, from application to presentation, presentation to session, session to transport, transport to network, network to data link to physical, physical data goes, or actual bit transmission is done here, and the opposite. This is the interaction between layers in the OSI model. So each layer, they have some interaction. The exchange using OSI model, every link does something, or every layer does something. For example, this data link layer, just above the physical layer, it adds some header, some trailer, somewhere the frames are formed, somewhere it deals with fragments, somewhere the packets are made, somewhere the actual synchronization is seen, somewhere the data is actually being transmitted. So all these layers does pieces specified and very crystal clear jobs that have been assigned to it, so that the data transmission is smooth and perfect. So layers in the OSI model, we'll see the layers. As we said, these are the 7 layers of ISO OSI model. We'll start with the physical layer. But before we go ahead, let us see what physical layer does. The physical layer is responsible for movements of individual bits. We know in transmission we talk about bits, not bytes. The speed is in megabit per second, or bandwidth in hertz, or say always we talk about the channel capacity, that is in bits per second. So these bits we are talking about bits because in transmission we only talk about bits. So it will be kilobit, megabit, gigabit, and so on and so forth. So physical layer is responsible for movement of individual bits from one node to another. This node can be gadget, they can be device, they can be networking devices, they can be systems. So what all are in between the actual bit transfer is done by the physical layer. Now we go back and we understand what physical layer does. So physical layer, here we have actual bit stream. This is the bit stream. There is a transmission media, so actual bit transfers from one point to another, and one physical layer sends it, the other physical layer receives it. Okay, so this is the data link layer coming from data link layer. So we'll see what data link layer does. So data link layer is like this, but before we go ahead, let me tell you what data link layer does. Data link layer is responsible for moving frames from one hop to the next. Now we are talking about frames, not bits. Data link layer is responsible for moving the frames. Okay, so what data link layer is doing? It is forming the frames with some header, trailer. The data is here, so it has got something from network layer. It is passing it to the physical layer, and in the form of frames. The exact inverse will be happening. I'll be discussing only this part because this, you assume it is the exact inverse of what is happening here. So we understood the data link layer. Now this is the hop to hop delivery in the actual system. This is end system, this is end system, end system. So hop to hop means this is one hop, this is another hop, this is another hop. So data link layer, physical layer, they are responsible from one hop to another hop, proper delivery. Okay, so now we see the network layer. So before I explain this, let us see what network layer does. The network layer is responsible for the delivery of individual packets, bits in physical layer, frames in data link layer, now packets in the network layer, from source host to the destination host. Let us see what data link layer and transport layer has to offer to the network layer. So network layer does what? It deals with the packets. So bit, frame, then we have packet. Okay, so transportation layer sends something or gives something to the network layer makes or deal with the packets, and to the data link layer it passes, where it will be in the form of frames. Next, this is the source to destination delivery. So the network layer is responsible for the hop to hop as well as the source to destination delivery. Now we come to the transport layer, what it does. Transport layer is responsible for the delivery of a message from one process to another. You have to understand it very carefully. Now in transport layer we are talking about the process, not bits. No, we are talking about the process to process transfer. Transport layer deals with the process to process. So in transport layer we have various data part, or so we can say segments. So now in transport layer, where these segments are there, this is being given to network layer in the opposite section. Exactly this is happening, the reverse order. So transport layer, delivery of message from one process to another. This is a reliable process to process delivery of a message. Say you have certain process, so this process to this process, this is the task of the transport layer. So for example, you have internet, so network layer is responsible from host to host delivery, but transport layer is responsible for process to process delivery. And the session layer, what session layer does? We need synchronization, we need dialog control. So session layer is responsible for dialog control and your synchronization. Let us see how it is done. So you can have a message like this or the data. So what needs to be done? We need to embed certain synchronization activities. This is done by the session layer. Why? Because there can be various sessions. So how to manage these sessions? There has to be synchronization. This is done by our session layer. Dialog control and synchronization. Then we come to the just layer below, which is application layer, which is the presentation layer. So what is the task of presentation layer? The presentation layer is responsible for translation, for compression and encryption. We want to translate from A to B, say A code to B code. You want that this is say 5 MB. You want to send it into say make it in KBs. You want to transfer it in KBs. Encryption. This data is important to me. I want to encrypt it so that the people in between should not understand it, should not retrieve it, should not say spoil it. So the encryption, translation and compression is done by the presentation layer. Okay. So in this you have a data, translation, encryption, compression done by a presentation layer. Now we come to application layer. What this application layer does? First see. The application layer is responsible for providing services. So some layers are responsible for host-to-host delivery. Some layers were responsible for your process-to-process delivery. Some were responsible for the translation, encryption, or the compression. But here, the application layer, that is the topmost layer, where you are involved, user is involved. So human or program will be there. Users. Application layer is responsible for providing the services. These are the services like X.500, FTM, X.400. So this is the task of application layer. So let us summarize it. We'll start with the physical layer. Physical layer is responsible to transmit bits over a medium to provide mechanical and electrical specification. Mechanical and electrical specification, transmission of bits, physical layer. Data link layer to organize these bits in the form of frames and provide hop-to-hop delivery. Network layer to move packets from source to destination, that is host-to-host delivery, provide the internetworking. Transport layer to provide reliable process-to-process message delivery and error recovery. So transport layer also deals with the error recovery. Session to establish, manage and terminate the sessions. This is done by synchronization. Presentation to translate, encrypt and compress data. Application layer to allow access to network resources. Then we come to the next one, which is the most talked one. TCP/IP protocol suite. So the layers in TCP/IP protocol suite do not exactly match those in OSI model. That OSI has 7 model, AP, ST, DP. The original TCP/IP protocol suite was defined as having 4 layers: host to host, internet, transport, and application. However, when TCP/IP is compared to OSI, we can say that TCP/IP protocol suite is made up of 5 layers. We have physical. We'll start with the top one: application, transport, network, data link, and physical. So data link is again divided into 2. We'll see about this. Logic link control and MAC. So we'll talk about the physical and data link layers. This one, network layer, and then the transport layer, and then the application layer. So this is the TCP/IP and OSI model. What all tasks they are supposed to do. First of all, you have application, presentation, and session. Doing the services work, SMTP, FTP, HTTP, DNS, SNMP, Telnet. Transport layer, here we have SCTP, transmission control protocol, user datagram protocol. In network layer, which is providing the internet networking, we have IP, internet protocol, and also ICMP, IGMP, RARP, and ARP. These are all address resolution protocol and reverse address resolution protocol. Then data link and physical layer protocols defined by the underlying networks, host to network. So let us see the addressing. 4 levels of addresses are used in an internet employing TCP/IP protocols. We have physical address, logical address, port address, and a specific address. So we'll talk about these addresses. Addresses in TCP/IP: physical address, logical address, port address, and specific address. So these are the relationship of layers and the addresses which are in TCP/IP. Application layer, we have processes, so they have specific address. Transport layer, for TCP, UDP, we need the port addresses. For network layer, which are IP and other protocol base, we need logical addresses. And for underlying physical networks, for data link and physical layer in TCP/IP model, we need the actual physical addresses. So let us take an example. You have a figure, a node with physical address 10 sends a frame to a node with physical address 87. The two nets are connected by a link, which is the bus topology local area network. So as we'll see the figure, the computer with physical address 10 is the sender, and the computer with the physical address 87 is the receiver. So this is not a big problem. This is just an example. So this is the physical addressing. This is the sender. This is the receiver. So now in this, the data is here. Data is here, but at various layers, what happens? This is the destination address. This is the source address. The source address is 10. Destination address is 87. So now this data along with certain trailer and destination address, this is sent. We have a LAN. In between we have 28 and 53, those addresses. But the destination address does not match with 28 and 53 because it is actually 87. But it does match with this receiver. So now nothing will be done here. The data will reach here and this will be taken up by this receiver. Because this data is intended to send to this receiver only. Other will be mere spectators. So we'll see in later section also, most local area network, they use 48 bit, that is 6 8 is a 48, that is 6 byte physical address using written as 12 hexadecimal digit. So every byte, that is you have 2 hexadecimal digit, which is separated by a column as we see here. These are a 6 byte, that is the 48 bit, or say 12, or these are, every byte has 2 hexadecimal digit, this one. So 6 into 2, that is 12 hexadecimal digit are there. This is a 6 byte physical address. And we'll see one more figure. It shows a part of an internet with 2 routers connecting 3 LANs. 2 routers connecting 3 LANs. And each device, which is computer or router, it can be computer or a router, have a pair of address, which is logical or physical, for each connection. So in this case, each computer is connected to only one link, and therefore has only one pair of addresses. Each router, however, is connected to 3 networks, only 2, which you will see in the figure coming up. And so each router has 3 pairs of addresses, one for each connection. So they have 3 LANs. There are 3 LANs. This is a sender, and you have a receiver. So the data from upper layers go to network layer, to the data link layer. Through LAN 1, it is taken up. But what is the address where it needs to be sent? This goes to, say, another network, which is X44. And again we have a router. This will route it to the LAN 2. This will go or reach somewhere here. This to the LAN 3. And then, because this is 95, so 95 data link layer, so this is the address. And because 95, this is from the LAN 3, this data is destined for this receiver accepts it. But if in meanwhile you see the addresses are changing. Why this address is, in this case we have addresses, say 66 or 99. So it has taken the address 1999, or say 66 from Z66, or say 33 from here. This is because these are the physical address which are changed. So these are the address changing. So ultimately there is no problem with this. There will be address change, but the layering make it possible, and the way the data is destined, it will reach from various LANs to various routers to the exact address. This is the beauty of IP addresses. Now we have one more figure. Let me show you the figure first. So these are the port addresses now. These are various layers. You have sender, you have receiver. So how these layers does the activity, we'll see in the previous slide. So the figure shows 2 computers. They are communicating via the internet. So the sending computer is running 3 processes at this time with port addresses A, B, C. And the receiving computer is running 2 processes at this time with port addresses J and K. So these are port addresses for first one, these are from another one. So process A is sending computer which needs to communicate with J. A may want to communicate with this J in the receiving computer. So we need to note that although the physical address change from hop to hop, logical and port address, they will remain the same from the source to destination. Only the physical address is going to change, because physical devices are different and they have a unique address, so they are going to change, of course, but the logical and port address, they are not going to change. In this case, this is the data. A wants to communicate with J. So A is the sender, J should be the receiver. This will remain the same, but it will be added with same address, physical address, header and trailer, but A and P, but A and J will remain the same. It will go to the internet and then come back. Here A and J is already there, A and P, then A and J, that is the data is received by J. These are the different tasks of various layers, what they are doing. They are doing their work which has been predefined to them. So the physical address will change from hop to hop, from one hop to one node to another, but the logical address will usually remain the same. And we'll see in later section, a port address is a 16-bit address represented by one decimal number like this, 753. This is the 16-bit port address represented as single number. 16-bit address, this is the port address. The physical address changed from hop to hop, but the logical and port address, they usually remain the same. This is all about our network models. Next, we are up for the data and signals. And then thank you so much. Take care.